All right, today's lesson comes from section 2.6, more factoring. Woohoo! The learning target, you'll notice that students will be able to factor trinomials to solve, which we've been doing. However, today is going to include trinomials where a is not equal to 1. Let's talk about what that means, and then we're going to jump into some strategies for factoring. Remember that standard form for our quadratic equations is y is equal to ax squared plus bx plus c, where a, b, and c, they just represent numerical values, right? They're the coefficients and then the constant at the end. So far, we've gotten to the point where either this a factored out with our greatest common factor, or it was just equal to 1. So, for example, we had something like x is squared plus 5 times x plus 6. Notice the a value there is not written as anything greater than 1, right? We assume there's a 1 if there's nothing written. So when that was the case, it was pretty easy to break this apart. We did x and we did x. They were both positive signs because everything is positive. And then we found factors of 6, like 2 and 3, that add to equal 5. So those ones worked. We used 2 and 3. Today we're going to look at examples where there is a value sitting right out front, and we're going to talk about how that changes it. So first of all, I just want us to recall the steps. So I know this is not part of the guided notes. I'm going to add in just a little sheet here, like as if we were talking together in class on the board. And let's just recall a few things. So kind of recall to where we're at so far. That says recall. It looks like, I don't know. Step number 1, all the time when we're solving by factoring, right, is that we make sure that we're set things equal to 0. So we want to set the equation equal to 0. In other words, move all the terms to one side of the equal sign, and then write it in standard form. So that's going to be big as we're factoring. Make sure that your equation is just written in standard form, right? We want the x squared term first. And then once we had it in standard form, we always factor out the GCF, the greatest common factor, if there is one. So there's not always a greatest common factor, but if there is, we always take that out first. And when you do that, right, the greatest common factor, whatever that is, comes out front and everything else stays inside. And then lastly, we talked about making sure that we finish factoring if it needs to be factored more. So we finish factoring if it's a trinomial. So that GCF is still out front, but now we broke down the trinomial maybe a little bit farther, so it looks like this. And then if we're solving, right, then we identify the solutions. So that would be kind of your last step there, is state the solutions. So we have x equals and x equals. Now remember, if we're just factoring and it's not equal to anything, then these are the only 2 steps we would need. We just factor out the GCF, factor the trinomial, we're done. We're just practicing factoring. So let's recall just an example using these steps that we've done so far. So an example would be something like we've got 5x squared plus 15x, and let's say we have plus 5 is equal to negative 5. So the very first thing that I would do is set it equal to 0. So I have a negative 5 on the right-hand side of the equation that I would add to this side, and I would make sure that I combined it with its like term. So I would have 5x squared plus 15x plus 10. Now that it's equal to 0, I look for a greatest common factor. Notice all of these coefficients or numerical values are divisible by 5. So we could pull a 5 out front and divide everything by 5. In this case, I would be left with x squared. 15x divided by 5 would be 3x. And 10 divided by 5 is a positive 2. Again, notice that a value right there is 1. Right? So this one's pretty simple to split up. I just break it into the 2 binomials, and I split up the x squared as x and x. All my signs are positive, so I know that these 2 will be positive. And then I look for factors of 2 that combine to make the middle term. The only factors of 2, right, are 1 and 2, and those do add to 3, so we're good there. Again, that's factored form, and then we state the solutions. So in this case, the value that would make this first piece be equal to 0 is a -1, because -1 plus 1 would give us 0. And then on the right-hand side, the x plus 2, that solution would be a -2. So these would be our solutions to this equation. Now, we're going to talk a little bit about when a is greater than 1, okay? And again, I'll come back to the guided notes page. But when a is greater than 1, right, what's happening? So let's look at an example here. Let's do 4x squared plus 13x plus 3. Now, notice on this one, if I start to break this into binomials, and I just go like this, and I say, okay, well, let's think about it. 4x squared, what would give me 4x squared? Well, it could be 4x and 1x. That's an option. But also notice that this could be 2x and 2x, right? In which case you still get 4x squared. So when a is not equal to 1, when it's greater than 1, the only reason these are a little more complicated is you have more options to choose from. And the more you practice this, the better your brain gets at connecting these without having to go through every option. You can kind of see which options are absurd and which ones are actually going to fit. But for these examples, I am going to lay out each option so that we can just kind of see what we're looking for, okay? So again, the options for 4x squared are 1x and 4x. Those are the only things that multiply there. And then 2x and 2x. Those are the first times first is going to have to look something like that. Okay. So I'm going to write this as here's our option 1. Here's our option 2. And then we are going to have a third option. I'll show you why. Then we look at our last times last, right? The middle term can change depending on what the first and last terms are, but last times last always gave us this last number. So factors of 3 would be like 1 and 3. Those are the only factors. So think about if we put 1 and 3 in here, and notice this is positive, and so is the other one, so everything, right, is positive. So I could put plus and plus. I know that all of these are going to be positive. Notice on this first example, though, if I start to FOIL this, and I multiply here, I get 4x squared, right? That's exactly what I want to get. I also get a positive 3. So the question is, what is the difference between these options? And the difference comes when you're looking at the outside and inside with our FOIL. So notice when I multiply the 4x times the 3, right? And I'm going to put a little O over here. The outside, when I multiply it, is 12x. Then I multiply the inside, so 1 times 1x. When I multiply that inside, I get 1x. Now, we can see that if I combine 12x and 1x, that does give me, so 12x plus the 1x, that does give me that 13x. And that 13x is that middle term that we want those pieces to combine to. Now notice the factors I chose were not 1 and 12, right? It wasn't as easy because the front numbers, or the first times first, they are also multiplying into those middle terms. So we do have to kind of go a little bit deeper to check for those factor values. But this one does work. So in this case, right, yes, this guy works. That must be the correctly factored one. Now let me show you really quick what it looks like as we look at the other options. So again, let's say we used the 2x and the 2x, so I'm going to put the 1 and 3 in here. And notice that when I start to factor this, again, the first times first is 4x squared, so I'm not going to worry about that. Last times last is 3. 1 times 3 is 3. But again, if we look at our outside, so the 2 times the 3, so I'm going to start there, that gives me 6x. And when I multiply the inside, the 1 times the 2x, that gives me 2x. Now notice if I add 6x plus 2x, that gives me 8x. So this guy doesn't work, right? That one didn't work. Now, you're asking, what is option 3? I'm sure that's your thoughts. Option 3, right? If I have the 4x and the x again, notice if I switch the 3 and the 1, and then everything again is still positive. Notice that now when I look at my outside, 4x and 1, that gives me 4x here. And if I look at the inside, 3 times x, I get 3x. If I add 4x plus 3x, I get 7x, which also is not the 13x we were looking for. So the order of your factors really does matter because it's determining which values are multiplying in your distribution. So in this case, our final factored form, right, that top one was the winner. So this guy, 4x plus 1 and x plus 3, this is the factored form for the polynomial that we started with. Okay. Again, let's look at another example listing out all the options. We'll jump to our guided notes in just a second. Let's do another example. So an example here would be like 3x squared minus 7x plus 2. Again, notice this is a sum, so I like that. That means that they're going to be the same sign, and it looks like we have a negative, so they're both going to be negative. Okay, so I already know that. That helps a lot. Again, I look for greatest common factor. Is there one? Not in this case, so we can just continue to factor. So the first thing, again, we look at our options for first times first. So this could be a 1x and a 3x. So if I'm looking to list a couple of options, this could be 1x and 3x. Then I look at the last value, and the only thing that multiplies to 2 is 1 and 2. So we look in here, and we know that this is going to be 1, this is going to be 2. And notice that if I still have that 1x and 3x, if I switch the 2 and the 1, that creates a different outcome. So we've got two options to consider on this one. And again, the nice thing about this is we know that both the signs are negative. So we just have to check these options. So again, if you look at the first times first on everything, 3x squared, right? Both options give us that. Last times last, we get a negative times a negative, which gives us that positive 2. So we're good there. We just have to check the outside and inside. So we do 1x multiplied by the 2. And it looks like our outside gives us a negative 2x, and then negative 1 times 3x. So that inside is giving us a negative 3x. Again, negative 2x minus 3x, or plus negative 3x, is equal to negative 5x. Our middle term here is a negative 7x, so this doesn't appear to be the one that's going to work. So we check the next one. 1x times 1. Again, that gives me a negative 1x. Notice inside times inside, negative 2 times 3x is giving me a negative 6x. So here we have negative 1x minus 6x, which gives us negative 7x. Yes, victory. That is what we're looking for. So our final factored one on this one would be like the x minus 2 and the 3x minus 1. That's the order that would work for factoring this out.